Oh man. So this is it, friends. Welcome back. This is our second tech panel. We had a good show back in November, and we appreciate everybody who joined us for that one. We talked about cloud and networking, and today we're going to be talking a little bit more about virtualization and networking and cloud and. So Jacob, Jeff, it's good to see you guys. Everybody doing all right today?
Doing just fine
Absolutely.
today. Yeah.
Glad to be here. Jeff's looking good.
Yeah, that's fantastic. These are our recording studios, friends. Too. If you guys have not watched the CBT Nuggets video, this is how it happens. We spend our days recording and making the training there. Yes, dodging the microphones. Oh man. Well, we've got a lot to kind of get into today. I wanted to jump in and start off by just talking a little bit about backgrounds. Ooh, something happened on my mic there. Guess it's back. Great. So a lot of news coming out. You know, we get people asking all the time about virtualization and the role that it plays in training for an information technology career. So we thought we would bring you guys some info today and answer some questions regarding virtualization. Jacob here is our VMware trainer and a number of other topics, and we wanted to get his viewpoint. I being a cloud instructor, I spent a lot of time talking about what virtualization enables for us, and virtualization has shaped the networking world. So that's where we're coming from. We want to hear from our panelists. And of course, we have questions that you guys have submitted in advance, and you can also follow along in Slack there. So for me, recently I went to reInvent. I guess this was back in November. And the interesting thing for me when I was talking at the AWS conference there, they're talking about the virtualization changes that they just made like within the last year or two. If you take a look online, AWS Nitro, that is their improved hypervisor, and it's something that's just hit the scene in a big way in the last just very recent future. And so even now in 2020, looking at all the things AWS has done, they're still evolving their virtualization technology to meet cloud workloads. So exciting stuff to see coming up again in this year. What about you, Jacob? Any news coming from the virtualization world that you want to share?
Well, yeah, when I was at VMworld actually earlier this year, something similar in that, there's been this progression to kind of make things smaller, more individualized. One of the things that we see is containers, right? Containerization, where we're running an app, not a whole VM, as a particular workload. And what's interesting is actually VMware's next version of their hypervisor of the ESXi and vSphere infrastructure is actually going to be based upon a container mode of delivery. Like they're rebuilding their entire infrastructure because it's so effective, because it gives better performance, because it ends up being more secure to not have, everything, a buffet of hackability, right? To narrow it down so that it's nice and clean and efficient. So yeah, we see that there as well. And I've seen a ton of things with people actually jumping on board with virtual networks. And in the VMware world, it's through NSX. But Jeff, I mean, we're seeing that there on the Cisco side too, aren't we?
Oh yeah, absolutely. Inside and outside the data center. I mean, yes, NSX, Cisco ACI, we get into some fun conversations around that, but ultimately they're all built on the same technology, which is VXLAN tunneling. I mean, we've evolved beyond virtual LANs, right? We've had virtualization in networking since, I don't know, sometime in the early 90s, I think, whenever VLANs were invented.
Yeah.
But that was limited in what it could do. And it really
Can you count to 1024? Oh, you're done.
extraordinarily. Well, technically we get a few more than that, but not much. And so in the end, yeah, VXLANs take us to 16 million network segments, all of a sudden. But then not just inside the data center, because that's where VXLAN really finds its home. But yeah, I've spent a lot of time lately in Cisco's SD-WAN technology. And when we're talking about SD-WAN, we're talking about Lisp at the control plane. We're talking about VXLAN at the data plane. And all of a sudden now we're extending policies throughout the network at a virtual level. We're talking about software-defined networks, yes, inside the data center, but also outside now. Again, software-defined WAN it's a really fun technology because we're talking about overlays over top of underlays, and now we can do whatever we want in the overlay, regardless of what's happening in the physical network. And so to abstract, it's a fancy word, but effectively it just means that we're going to, when we're saying abstract our policies, we're taking it into that overlay level. We're saying we're going to deploy our policies here and let the network handle itself down here. And so it's just, where networks are going right now. I mean, it's the most forward thinking, I think, that we've been in from a networking perspective, just from a pure route switch perspective, in probably 25 years. Even probably 10 years ago, it was like, well, not a whole lot different than the early 90s. You got your Ethernet headers, you got your spanning tree, you got your VLANs, but buckle up because, we're moving at 100 miles an hour all of a sudden.
Well, so much of that ties into our kind of holistic desire to be scalable, to be automated. I mean, there's so much in the way of DevOps that is kind of touched every aspect now, where there's this expectation if you can't make this a systematic, automated process, then you're probably missing the boat. You're doing something wrong. You're doing more work, and that means we're paying you too much. So everyone's got to try and figure out how to be efficient. Uh, Trying to dial that in means understanding, often a large array of technologies. How much, when we talk about the different technologies that you need to know, like what are some of those key cloud technologies, Bart, that you feel like are kind of the ones that you want to have in the front of your mind?
Oh, sure. Yeah. So whenever people get into looking at the cloud discussion and we want to get into the cloud, we want to get a career going in the cloud,
Mm-hmm.
they often say it as if cloud is a technology in itself. And in general, I like to dispel that myth pretty quickly. I think of cloud as automation, virtualization, and networking as really the core technologies of it. Cloud computing itself is more about service availability of those technologies that we need. And so that's kind of where it gets exciting for me. Along those lines, you guys we threw a lot of great terms out there. I was thinking maybe we ought to find out what level our crew is at. So our friends out there watching online, we'll throw a poll up on the screen here for you. Where do you sit in the grand melang of virtualization? Have you run some VMs? Do you have some experience working with hypervisors? Maybe this is your first go around. Maybe you have experience with some of those other technologies you heard me say in there, automation, virtualization, and the networking pieces as well. So go ahead and put some submissions in. You can kind of see the responses coming in. I'm curious, while we're watching this, Jeff, have you had a chance to install a hypervisor in your career there, or are you working more on a higher level on it? I'm just curious.
That's a fair question. Most of the time that I've spent doing deployments is on the network itself. But I tell you what, when it comes to labbing things up and trying to, hey, I'm ready to experiment. I want to deploy VMware onto UCS and deploy maybe a virtual switch into my VMware space. At that point, I'm deploying my own hypervisor, right? So I've done quite a few hypervisor installs within my lab environment.
Awesome. Yeah, and taking a look at the results here, looks pretty good. Looks like at least half the group has worked with some sort of virtualization. Maybe they're using some tools now or managed some VMs. And it's a broad array of things you could have worked with. We got VMware, you got Red Hat flavors, you got Citrix, you got Microsoft out there, and then of course all our cloud providers that we have available now as well. So this kind of getting back to Jacob's question about those core technologies, Jeff was mentioning too, abstraction. And I think that was the original reason we really got into virtualization, was the idea of taking something big and physical and inefficient and breaking it up into smaller pieces. We used to have to buy big servers and then we'd often not use them. That was one of the things that really won for me when I first started using lab infrastructures, was that I could put a whole bunch of machines on one piece of hardware, where before it was just the one role. So I'm sure, Jacob, you might have had some good experiences with that, and it's gone even farther since those days.
Oh yeah, I mean, it's because you had to justify, right, every expense, because you'd have really a need from a performance and security standpoint. I want to have an application running on an operating system, which meant it had to run on a chassis. And so all of the expense that goes into the hardware then trickles down to the expense of an individual application. And now, we turn that around and we're free, right? We're free to be able to kind of essentially have a boatload of resources that we purchase and then dole them out to the virtual machines. It's all about partitioning and allocating those hardware resources, disk, memory, CPU, network, video, and being able to allow those VMs to do that. So much so that, I mean, we do that for server infrastructure, but we also are seeing more and more virtual desktop infrastructure, VDI, where I can have my desktops available, a personal desktop, or maybe it's not personal. Maybe the whole point is it's a standardized desktop. I can sit anywhere in, like we see this all the time in the medical industry, right? Sit at any terminal and I've got the things I need showing right up, but it's not, it's remoting into a virtual machine. And between the network capacity having gone way up and being way more efficient in the way that it's able to allow us to remote into these virtual machines, and then the way that we can really fine tune these virtual machines to support a desktop that we need that has just enough and not too much, right? Trying to avoid the bloat. And, we're able to just, again, have all sorts of options that we wouldn't otherwise have. Oh, I'm not hearing you, Bart.
The mute works great. Appreciate it, Jacob. Yeah. So I think one of the things that I meant to share the poll here too. I don't think I shared the results. There we go. Look at all of our nice poll results.
Oh, beautiful.
Okay, so we got a gathering of experience out there. Now, for me, I considered virtualization something that if I hadn't had a chance to work with it, I don't know that I would have been as successful in the cloud computing industry without understanding that technology. What do you think, Jeff? Has that been something that's made a differentiation for you in the networking world?
To say that one more time, Bart. I'm not quite sure I followed you.
Differentiation. It was a fun word, and I'd like for him to say it again.
Differentiation. So the question is, Jeff, is it really, how crucial is it for a networking gig? Is that going to be
Oh, yeah.
a characteristic for you?
Well, the poll is striking, right? Because 8% of responders said that they work with virtual networks regularly, compared to 42 saying virtual machines. And I understand you had to pick one there. You couldn't like say I work with both regularly, and the bottom is sort of the catch-all. But either way, I mean, just the breakdown as a snapshot does tell us that virtual networks are not as pervasive yet as virtual machines. I mean, to find a data center these days without any virtual machines, I mean, short of somebody who's gone total containerization or something like that, you're beyond virtual machines. But to say that there's a data center out there that's really running significant workloads without a virtualized environment is, it's going to be a needle in a haystack conversation. However, at this point, we're still at that very intro level of getting these virtual networks out there. If you're not running Cisco ACI, if you're not running VMware NSX, there's not a whole lot of opportunities. I mean, maybe you're building your own VXLAN tunnels, but kind of the point of all of this is to automate and orchestrate it as much as possible. So we want those tools to help us go out and deliver the complexity of VXLAN tunnels, but streamline it, make it simple for us. We're trying to virtualize the network while making it simple as well. But I mean, the reality is that that's an extra cost. And if I'm going to virtualize my networks, I need to purchase VMware NSX or what have you. I need to make that investment. And so there's a lot of data centers out there, I'd say, that are on that threshold of trying to decide, is it worth it to make that investment? And until that happens, I don't know that we're going to get, again, a poll like this. We're going to see a lot less people with experience in that. So now's a good time to jump into the labs and get some hands-on with it, because the need is just going to go up.
Well, and Jeff, one thing that came to mind here, I'm thinking a lot about hireability, because this is a lot of the questions are around hireability and what does this mean from a career perspective.
Yes.
And people have regularly just been asking me, do I really need to know virtualization to get into cloud? Because don't the service providers hide that from us, and don't they simplify a lot of that? And I say, yes, you're right.
Don't look at what's behind the curtain.
Yeah, right.
Yeah, no, absolutely. Yeah, watch out for Oz. I mean, he's definitely cooking back there. But for me, I try to get people to think like, okay, well, you're asking me what technologies you want to learn, and I'm going to ask you, what job do you want to perform? Because in the end, that's really the biggest question with every one of these discussions, is if you want to work for an internet service provider, you probably will work on a lot more virtual networks than if you're running in a data center in any small, medium-sized enterprise.
Yeah.
And same idea with cloud service providers. If I want to go work for a local regional cloud service provider, we're going to run hypervisors. We're going to have a management plane. We're going to have control over all of that. The cloud pushes stuff off of consumers. It doesn't push stuff off of the providers. So if we're looking to work for those providers, then we're going to need the full gamut of experience. And you better believe that no matter what cloud does, there's still providers in the background. So I was thinking about that, Jacob. What do you think about the difference between like enterprise, maybe even some of the difference in hypervisors? I imagine the job role carries some of that with it.
Well, I mean, one of the things that sometimes when we're talking about hypervisors, one of the things that comes up is this idea of a type 1 or a type 2 hypervisor. And sometimes that differentiation is interesting. A type 1 hypervisor is where literally the operating system on the hardware is a hypervisor. It is there to support virtual machines. That's its only job. Whereas a type 2 hypervisor is what's considered software. So you have hardware, you got an operating system, and then you install this software, and that software then provides a virtualization infrastructure. It allows you to run virtual machines, but it has to run through the application, through the existing operating system, down to the hardware. It's just another layer. one of the things that allows type 2 hypervisors to do is to be very useful for like testing and lab work and development, because on my desktop, I could just spin up maybe a VMware workstation, for example, and bam, I've got a place where I could test Red Hat and I could test Ubuntu and I could test Windows and see how things perform. Even phone operating systems can be virtualized now easily. It's a lot of fun. But then type 1 hypervisors are like, the big hypervisors that are running in the background. They're hosting, all the databases and mail servers and network infrastructure services that we need to support. But then as we then move even further into technologies like NSX and technologies that are supporting the network, the routers and the firewalls and the load balancers, these network appliances that we would think of as, something we slot onto a rack, we can have those be virtualized too. And it's not that we don't still eventually need some physical wires to be able to connect, one place to another, but that's part of the beauty of the virtualization world and some of this network virtualization that we're moving to as we kind of push the boundaries of what virtualization allows us to do. We find, oh man, I'm stuck in this little box because I can't get from one network to another. So creating virtual worlds where there's virtual networks that allow the virtual machines to believe that they are side by side, even though physically they're not, because they tunnel through the network. And the physical network doesn't even have to know about it. And I think that's the thing that is so amazing about virtual networks. In the same way that a virtual machine doesn't know it's not really running on physical hardware, except in some exceptions. In the same way, they don't need to know that they're not connected to the physical network, that they're running through this little transparent network that is allowing localized connectivities. And then this starts to get even crazier, because one of the cool things that we can do is we can have virtual machines that are running their various workloads in our data center. We can have virtual machines that are being hosted with infrastructure as a service in the cloud. And then one of the cool things we can do is maybe I'm hosting web services, and normally I just like to do that with my on-premise web servers. But if there's a burst of activity that's coming out, running a sale and suddenly, all these people are connecting in, then that could be bursted up to the cloud, and suddenly virtual machines that are essentially load balancing to more web servers that are being used on demand. And that subscription model and the flexibility and the burst options are things that you could never even dream of doing. But that goes back again to the networking. All those VMs need to act like they're a part of a common network, even though now we're talking about things that are like based on different technologies completely. It's mind-blowing.
See also abstraction. Is that what you're talking?
Right.
Yeah.
I come back to that word a lot.
Yeah, absolutely. I was going to ask Jeff, one of the things that I like to bring up, we mentioned logical and physical originally.
Mm-hmm.
We're going even further. We're going logical on top of logical on top of logical. So
Yeah.
It really is abstraction to suit the purpose here. And to Jacob's point about bridging large disparate networks, this is exactly where things like ACI, software-defined networking for WAN, this is exactly where I think a lot of those pieces come into play, and they depend on things that are abstracted like APIs to help drive that functionality as well.
Yeah, let me paint a picture, because I think, again, we probably all understand virtualization in the server world to some extent, just understanding the concept of virtual machines. They've been around for what, 12, 13, 14 years, if not longer, really, in the early days. But software-defined networks are very new, and we've been hearing buzz about them for longer than really they've even been real. So what really does it mean? Let's put some teeth to this. And one of the best examples that I like to give is, think about the access layer. So for those of us who are networking junkies, we understand that the access layer, we have kind of a rock and a hard place conversation there, because we need to decide if we're going to extend layer 2 to the access layer or layer 3 to the access layer. Layer 3 is very clean. Ideally we extend layer 3 because we don't have to worry about spanning tree loops. We don't have to worry about maybe first hop redundancy protocols, and there's just all kinds of complexity that's extended by layer 2. And yet most networks extend layer 2. So why do we extend layer 2 instead of layer 3? Because we need some of our clients to be on the same VLANs, to be on the same subnets. And if anything, it's actually getting worse, because back in the day it used to be, oh, if I want to do file shares between computers, they need to be on the same network or what have you. Number one, we don't do a whole lot of file shares between computers anymore. Usually it's vertically into our data center or to the cloud or what have you. And maybe printers used to have to be on the same subnet. We've gotten away from a lot of that. But the Internet of Things where we've got coffee makers connected to refrigerators, to connected to what. A lot of that is being built around the assumption that we're all in the same subnet. And so when we're relying on that capability to do broadcast traffic, we have to extend layer 2. Otherwise, we have to have different subnets per, basically per access switch. So again, I don't know how much of you are, deep into the networking weeds versus deeper into the server or storage side of things. But to conclude this, when we're talking about abstracting, building, Bart, to your point, logical upon logical, the original logical was just the conversation I just had. Like, we need to decide where our VLANs go and how far do we push those, because that was the logical topology, subnets and such. But all of our policy was bound to those subnets, bound to the physical underlying. Like, again, is it layer 3 or layer 2? And so my policy conversation is intermixed with my physical conversation, intermixed with the logicals, and it's all just a big mess. Whereas, okay, now what we've got now is this physical and logical topology that we can simplify. Let's make it all layer 3 everywhere. Let's just make it layer 3 everywhere, clean, easy, efficient, and then we'll draw whatever kind of topology we want on top of that. That is the abstraction. That is what we call an overlay. We're using VXLAN as a tunneling mechanism to make this happen, and without going into those details, because they're kind of irrelevant, effectively now I can run layer 3 to all of my access switches and yet allow all of my devices to be on the same subnet. Well, how does that happen? Well, only via VXLAN, only via this abstraction, this overlay, this software-defined networking, insert next buzzword here, right? I mean, but this is one of the ways that we can simplify our lives. We can get rid of spanning tree. We can get rid of first hop redundancy protocols by leveraging Anycast gateways. And I understand that some of that still sounds a little heady, but at the same time, what we're doing is we're deploying policy, whatever policy we want. Machines can talk to other machines even though they're not on the same subnet. Machines can't talk to other machines even though they are on the same subnet. We're able to define whatever policy we want independent of the underlying architecture. That's abstraction.
Yeah, that's killer, Jeff. And I was going to say that reminded me of another key aspect that we often get into, and that's the idea of multi-tenancy or concurrent workloads, sharing and cohabitating logical spaces like you were just describing there. When I think about AWS running all of the millions of customers that they have out there, isolation is a paramount concern for them, and keeping those workloads efficient and enabled while still separated is kind of the magic trick that a lot of them have to get into. And Jacob, I was going to throw it back over to you. Any thoughts on isolation or some of the gotchas there?
One of the terms that in the VMware world that they love to throw out is the term microsegmentation, which is basically another word for policy, right? That Jeff was just throwing out there. It's this idea that we can be programmatic, that we could have essentially an automated routine that can bring up multiple virtual machines that are designed to do, let's just say, a 3-tier web application, right? So we could spin that up. We could spin up a network that's associated with that, but the network that they join, as Jeff was saying, doesn't have to be an isolated network. It could be something that is a part of a larger network, but because of the tags that we could associate with these VMs, we could programmatically say, this is a top tier, it should be able to talk to the internet. This is a middle tier, it should be able to talk to the top tier. This is a bottom tier, it's a database, so it should be able to talk to the middle and top tiers, and that's it. And we could spin all that up, both the networking side of it, as well as the actual, CPU and memory and traditional virtual machine resources.
Yeah.
And then the crazy thing is, this host that is supporting these 3 virtual machines is getting overloaded. Well, that's fine. We can relocate the virtual machine, automatically migrate it over here to another host, migrate it up to the cloud, and nothing changes for the end user. Nothing changes for the security model that's going along with it.
Yes,
so
that's huge.
a lot of those things that were cloud and huge data center services only are working their way down to what's still a traditional, like, we're not talking containers here. These are still just traditional VMs, but we're gaining so many freedoms. And in this age where when breaches occur, when network attacks occur, companies are vulnerable, they're exposed, they can be wiped out very quickly. It's that question of, is it worth the investment? And sometimes there are performance reasons that push that. Other times it could be looking at things like compliance or trying to, or just, the area, like you're working in government, you're working with financial institutions, you're working with medical information, you work for the fire department. All of these things are going to have more strict concerns over how you manage that network. That, again, I love the ability to be flexible. I love the fact that what used to be a development environment was difficult to handle or required me to hand them a type 2 hypervisor and say, well, go figure it out on your own. Now we can have our infrastructure in place. We can delegate even the ability, okay, here's make some API calls. Here's a model for if you need to have X environment, spin it up for yourself, and it could build it up, let them work with it, save it, snapshot it, delete it. I mean, so many things are possible and desired, and microsegmentation is one of those key technologies I think that is worth learning about. It's kind of a one-off from software-defined networking.
Man, that is some great stuff, guys. I really appreciate the look from each viewpoint here, and really recognizing too that virtualization just comes in so many different flavors. The big core tech is server virtualization. Like, how do we run VMs? But beyond that, we're talking APIs, and we're talking about network abstraction, and of course, adding all this automation. You can see how, when we characterize it this way, you can see just how much of this enabled what we think of as cloud. That's where it all came from. You start automating those pieces. You add self-service catalogs on top of it to trigger things in the background through APIs, and that's how we arrived at the cloud computing discussion. So you guys probably noticed I got my funny little spinning wheel back here, and I noticed we got so many attendees. I'm just so excited to have everybody here. I thought we'll give this thing a spin. We'll give you guys a little trivia question. So let's see what the trivia question is going to be.
Come on, Blue.
Oh, it's a virtualization question. All right. So hey, friends, tune on in here. Let's see what you think about our next question here. We gave you a lot of info about virtualization. Just came flying at us. So let's see. What do you think now? How would you define virtualization based on what we've been talking about here? Of course, just like everything else in the tech world, you can always say, it depends.
No, you can't. It's not an option. I don't see it.
I took that option off because we need to have a bigger conversation on it. So you guys go ahead and submit your answers there. This could be based on previous experience. It could be based on what you've heard us talking about today. If you want to shamelessly Google, you're welcome to go do that as well. I particularly like the one on here about dual booting. That was always a really fun thing for me when I first started getting into PCs. Of course, it's kind of a funny convention to think about now. It's not going to be something we're going to be required to do very much. All right, cool. So our answers are coming in here. Man, we got a smart group. Most everybody's getting it pretty good. There's 68% voted. Fantastic. I appreciate everybody participating there. All right, well, we'll go ahead and close those and share those results back out. Look at that. All right, did you get your
strong in the world of software abstraction of resources?
Yeah, how many times have we heard that word today?
Abstraction.
That is awesome.
And what's interesting is these other answers, that people chose. I'd agree. Software abstraction of resources, right? Whether they're network or CPU or memory or disk or whatever it might be, right? The abstraction, the fact that it's virtual, right? It's not the real thing. But it'll get you to the real thing. But I'm not going to show you the real thing. And trust me, it'll be better because it's flexible. It gives us other options. And so being able to install multiple operating systems that are, because we're running multiple virtual machines, right? These answers that we see, which is a data center management technique that allows us to move these things all around. Again, whether we're talking about the VMs or the network or whatever else it is, those are all benefits. Those are all, features or things that we gain because of the software abstraction of resources. So yeah, that's kind of our baseline, and everything else just kind of springs up like a flower out of it.
Oh, there's so many great examples of logical and physical. Just think of like a disk. I mean, I think of saving stuff to my desktop. That's like 5 abstraction layers away from a piece of binary magnetic info. My application doesn't even think about writing to the disk. It submits something to the Windows subsystem and they handle sending it to the disk. I mean, it really is one of the oldest conventions around. Hey, thanks for answering the surveys there. Go ahead, Jacob.
One of the technologies that I wanted to briefly talk about, almost just to kind of put it aside and say, when we talk about the term hyperconvergence, that's one of the few technologies that doesn't get to play in the cloud, because it's actually kind of the reverse process. when we think about
is
the way
true.
that most of our data centers are traditionally set up, there's a bunch of servers and they've got some sort of fat pipe to a storage area network. And that's where all the disk resources are held. Some sort of typically a storage appliance or appliances are set up, they're on the network. And so that's our fiber channel or iSCSI, right? These types of technologies. And somewhere along the way, someone had the idea, well, okay, we've got all these servers, these servers, and we've clustered them together. They're all aware of each other. They're all able to provide failover for each other for things like CPU and memory resources. They can move a virtual machine over in terms of processing over to another host. But the reason why they were able to do that is because everyone can talk to this central storage area network. As long as they can pull the files up, then we're good to go. So what if, in the world of hyperconvergence, those files were stored on local disks? Since we're all clustered together, what if we took each of our local hard drives that were on these chassis, these hypervisor chassis, what if we took all those disks and combined them into a pool of disks? And so when I need to create a virtual machine and create the files that are associated with that, I would lay those down on the disks, and we'll all have access to each other's disks over a common network. So it's taking the appliance and kind of embedding the appliance distributed disk model into the hypervisor host themselves. So and why wouldn't that apply to the cloud? Well, again, in the cloud model, that's the opposite of what we're trying to do, right? The whole thing is it's all being abstracted into that world. Even in a large data center, this is usually, we're losing some of the benefits that a traditional storage area network has, but we're gaining the benefit of, hey, I've already got disk resources set up in the server model. I can just go ahead and utilize that. So hyperconvergence is a cool technology, but it's really a mid-size technology. That's where it's kind of hits its sweet spot. I don't want to invest in a large storage area network that's more than I need. And that's where, but again, it's just another form of virtualization. You're not really, as you were just saying, Bart, I'm not really laying things down on local magnetic data. I'm not seeing that. It's yet another layer of abstraction.
Yeah, I loved working with things like DRBD and some of those other interesting block replication technologies, because that's really what's happening in the background. You're creating a distributed file system. Love it. And a lot of these things could not have happened without the predecessor technologies evolving along the way, and keeping in mind that the networks had to grow along the way as well. One of the biggest things that AWS talked about at reInvent this year was how much high performance computing forced them to touch all of these things all over again. Once they started looking at the way that groups of high performance nodes have to talk, the level and the latency that they require of it, they had to rethink everything about the hypervisor, the way that they talk to the network controllers, the way they talk to the SAN controllers. Everything had to be written. And along that line too, it's interesting because we talk about hiding physical, but they spent a lot of time working with custom hardware to get over those last hurdles. The pieces where the ASIC logic down in the circuitry does a shortcut, helps keep improved transparency. And I know, Jeff, you probably got some similar stories about network performance improving. ASIC logic is back in a big way. Programmable ASICs and things like that, gate arrays.
Yeah, I mean, hardware, there's been a decade, maybe even 2 decade long attempt to get away from hardware. I mean, we're sitting here talking about software defined this, software defined that, abstraction, right? All of these things happen at a software layer, hyperconvergence. Jacob, to your point, right? I mean, it's underlying hardware, but there's software, there's a software layer that manages it all for us. And so, in theory, software is the best because it's the most flexible. You can do whatever you want with it. You can code, we could talk about APIs and interfacing systems to other systems and subsystems to subsystems. And yet, at the end of the day, hardware is, I mean, number one, all of this has to run on hardware at some point, right? I mean, Amazon, it's up in the cloud, but they've got their servers and they've got their storage and such. There are actual physical disks in the Amazon cloud. But at the same time, when we talk about this ASIC concept, that's application specific integrated circuit, ASIC. When we talk about these ASICs, they are fundamentally built for to do one thing very, very well. So yes, completely inflexible, right? a traditional ASIC, but software can't touch the performance of it. And so that's why, for example, for anybody who's out there that's a Cisco networking specialist, we talk about Ceph switching, right? I mean, so we had this old concept of process switching, and this is 20, 25 years ago, right? I mean, routers would get packets in, the CPU and the software would have to look at the packet, take the layer 2 header off, look at the routing table, build a new layer 2 packet and send it out. And then they evolved to Ceph switching and the ability to put a lot of that into hardware. And so there's hardware-based Ceph switching out there and such that can bring things in very, very quickly and turn it around. And so the CPU doesn't have to do nearly as much with it. And so when we're talking about just having ASICs, again, there's value in hardware. And so even to hear that Amazon had to look at specialized hardware in order to solve this problem is kind of an ironic, it's almost something we can laugh at, right? Because Amazon and Facebook and Microsoft and all these companies, they want the white boxes. This concept of, I don't care where it comes from, it's just compute, it's just memory, it's just hard drive space, doesn't care. The magic is at the software layer and how we abstract and manage that and dole it out to our individual tenants. Now, Bart, you did mention programmable ASICs, and programmable ASICs are a new trend in that we're trying to develop hardware that can adapt, because there are times when Cisco actually just did this. They put out for years and years, they had the 3560s and 3750s. These were, a non-stacking version, a stacking version of the same switch architecture, and most of us probably have interfaced with one of these types of switches at some point in our careers if you touch networking devices. And so they came out a number of years ago with the brand new replacement for those, and it was the 3650 and the 3850. And they actually had programmable ASICs in that architecture. Now, it was a version 1 of programmable ASICs. There wasn't even really known to be much of a thing when these came out. But it's a good thing that they did, because within about 2 years, I think, of them creating this new platform, which, you'd expect Cisco coming out with a platform like that to last 10 years, like the other ones did. Within 2 years, there was this concept of VXLANs and SDNs and overlays and all these things. And the 3650s and 3850s were not built for that architecture. And so Cisco came out with the Catalyst 9000s, and this is, all of their software-defined access is built on these Catalyst 9Ks. But had they not had that programmable ASIC architecture in the 3850s, they wouldn't have been able to integrate that at all into the new architecture. Yeah. But with a software update, they were able to push down to the ASIC some of the functionality. So it's not, the dream is that they would not have had to come out with Catalyst 9Ks, right? The dream is that they could have completely overhauled the ASICs from a programmability perspective. They were limited enough that they weren't able to do that. They still needed these new ASICs. However, there's just the fact that they were programmable meant that they could incorporate in on some level. And so it's not a complete refresh for those individuals who already went out and upgraded their entire network to be on 3650s and 3850s. So that's a story where we see that programmable ASICs can really future-proof hardware when you don't know what the requirements are going to be. And we live in an age where every 2 years, the requirements are new. So, I mean, I take it you see that, Bart, in the cloud world, right? Just as far as what the customers are looking for, what we're looking for out of our cloud has to change every year or two, right?
Oh yeah, if you guys have ever heard the term long tail effect, I mean, we get all of the problems for most of the customers all lumped in one end, but then you get into all of the crazy minutia examples of what people need for this use case, for this security requirement, for this location. And of course, most of the big providers are successfully targeting the top percentage of that. They're not trying to tailor everything to all of those other ones. But one thing I was going to ask Jacob about too is a lot of organizations struggled. They went down the special hardware path, and I'm looking at my non-x86 workloads out there and my Suns and my Spark systems, and there's a bunch of companies right now still trying to figure out how to virtualize those workloads. I don't know, what do you think about that, Jacob? x86, why is that important to what we've been talking about here?
Can you hear me? Just checking. Okay.
Yeah.
As we look at our server workloads and kind of what we've standardized on, I mean, at this point, like the type of processor type technologies that we're focusing on often are, again, purely an AMD versus Intel question and being able to kind of pick one of those flavors and kind of walk down that path, that still is a bridge that's difficult to cross. One of the questions that comes up a lot, I find, is working with NUMA, right? So non-uniform memory architecture, because virtualized workloads that are existing on top of hardware, well, that are existing on top of a hypervisor that's running on top of NUMA-based hardware. When we work with NUMA hardware, what happens is some memory is better than others, right? So as you have multiple sockets with the cores on those sockets that are associated with localized memory can have very fast memory response time. But as we start adding these workloads of virtual machines that end up crossing into the non-uniform, the other guy's memory, then we end up having kind of this long, more circuitous path. And so it was a decision tree that was made a while back to focus on that instead of going through a centralized bus, which for kind of, or a centralized controller for memory, which ended up being a performance hit, right? There was just always a bottleneck as we ran our larger workloads. One of the things that we end up seeing, and this is kind of what you were talking about, Jeff, is now there's this need to, when I set up a virtual machine that's going to be running like maybe 8 processors, I actually want to make sure that I'm dialing in correctly the number of cores to expect, which then relates to the number of sockets, which then ties into efficiently using NUMA. So we still end up with these hardware-related decision trees that we have to figure out as we're trying to get the most efficient performance out of this, which again is one of those things where, you know, Bart, as we were talking about the, you know, the benefit of running in the cloud is those kinds of things are being automated for us, right? And that's the thing, is we can do that in our own local systems, but we've got to come up with our automation technology to make sure that we're rolling things out correctly for the hardware that we actually have. We're in the cloud, that's assumably, hopefully, if they're doing it right, been done for us, right? Oh, actually, before we jump into that, can I share a little question, a little Q&A with our friends here?
Oh, let's do it.
All right, I'm gonna go ahead and share my screen. Let me pick a screen here. Looks like that one. Okay, so we should be seeing a CBT Nuggets screen. And on the screen, I've got a question for you, and you can chat in the answer.
You guys can use the questions box, or if you're in the Slack channel, you can respond on there as well.
Yep. So the backbone of the internet, 1991. What network technology was being used?
Plug and pray? That's what I'm going with.
So as you look at all these fat pipes connecting us, when we dialed in, oh wait, we were past dial-up at that point, right? Barely?
Just barely.
91?
Depends on where you lived, right?
Yeah. I didn't have high speed in 91. I was dialing in still.
Oh, no. Yeah, I was going to say, I think we were dialing in till at least 95.
Yeah, probably so.
Oh, we got one down there. John said ISDN. Rudy said dial up.
Those are good thoughts.
Those are good.
All right. Big reveal. 1991, the technology we were using. The T3, that was the backbone, right? We might connect in with modems or ISDN, but that was it. And this network, so back in the day when we were running these types of speeds, that was, I think I got a little pen here, a whopping 44.736 megabits per second. So
every one of those orange lines is a 44 meg string.
Yeah, that whopping 44 megs, which again, that's just, as we think about what we're expecting now, those pipelines now are running at what, like 100 gigabit per second, like huge fat pipes. Again, doing the math, that's 0.04 gigabits per second is what we were running. That was our internet, 0.04 Gbps. So yeah, it's the ability to use the cloud is based upon the fact that in the backbone, working its way down to the desktop, we've got so much bandwidth, we've got so much pipe to work with now. And yet, I've heard actually that there's some concern over that because of things like 5G networks and the expectation of how much more data every single device has the ability and the expectation to put on those networks. Jeff, as we think about trying to support these increasing demands, like as someone looking into getting into the industry or getting, figuring out their next position in the industry, what kind of concerns does that bring to the table?
This is the fundamental question behind Internet of Things, right? So for those who have heard of this concept of IoT, you think Internet of Things, what haven't we all had, hasn't the internet been consisted of things for a long time? But I know that's
thing two.
That was one of the first questions I asked.
These are
like
new things, Jeff. They're new things.
but this is more than just okay, Jeff has his laptop in front of him, Jeff has his phone, Jeff has a tablet. Okay, so I've got 5, 3, 4, whatever, how many things. I remember there was a time when my local wireless here in my house had like 5 things connected to it. Now I log in and there's 25. I'm like, what is connected to my wireless? But it's everything, right? It's my thermostat, it's my video game systems, it's my, again, phones and tablets and kids things and everything. And so yes, there's a proliferation of things, and that's part of it. But we also have this concept of machine to machine traffic. Machine to machine traffic is when you have machines talking to other machines. And so when you have sensors out in a farming field, for example, those sensors are not coming back to my laptop for me to run my own analysis. Those, can you imagine?
You'd be so busy.
Oh yeah, let's turn the sprinkler up over here. Well, yeah, you almost like imagine NASA mission control for one farming field. But of course not. We have a system that's designed to take all of that machine information and do something with it. And so when you have this proliferation again of machine to machine traffic, what that means is now our internet, the number of nodes on the internet is increasing at an exponential rate. Because it used to be like, okay, yeah, most maybe early days, a quarter of the world had a device on the internet, and then later on, maybe half of the world had a device, and maybe a quarter had 2 devices, and as we ramp up again, even if every person on the internet or in the world had 5 devices on the internet, it wouldn't be that large. But as we are deploying more and more things that are talking to other things, I mean, the amount of traffic that we're generating is huge. And it's not just like, okay, yeah, Netflix consumes a ton of bandwidth, but at least that's just one process. That's one set of flows. Mm-hmm. This is devices all over the world talking to devices all over the world. And you start to imagine this full mesh of thousands, hundreds of thousands, even millions of devices. It's getting out of control. This is really what it comes down to. And so what does that mean for us, especially if you're in the networking field and you're just getting started? Number one, don't forego the basics. Bart, you'd mentioned earlier the question of, well, if I'm getting into cloud, do I really need to understand hypervisors? Well, yeah, you need to know what's happening under the hood if you're going to go into that space. So same thing with networking. If you want to get into virtualization of networking, if you want to get into Internet of Things or overlays and underlays and such, that's great, but you have to know the basics. So don't forego the foundations. Get your CCNA, understand your routing and your switching or what have you. You've got to understand basic packet flow. But as you get above that CCNA level, now you're looking at different options. Internet of Things is, really tied to automation. We need automation concepts, orchestration, software-defined networking. This is designed to help us wrap our arms around this enormous, growing network. We thought the internet was huge in 2019. I mean, it's going to be what, 10 times as big by the end of this year. I don't know the stats, but it's exponential. We're in this exponential curve right now. It's getting more and more complicated, and the world is going to be relying on us as experts to have the tools that we, to give them a solid, like what was the word I'm looking for, like a robust network. John Chambers, he was the former CEO of Cisco at a Cisco Live within probably, I think he retired in 2015, 2016, something like that. One of his last times he spoke to the CCIUs. I happened to be part of that group. It was an honor to be sitting there listening to him on one of his last times talking. And he said, he was addressing the concern that all of us as CLI geeks, right? We love to sit at the CLI and punch out commands. He addressed this group that said, I know you're all concerned about us replacing you with these automated and orchestrated tools. He said, the way I see it is we're not replacing you. We're giving you the tools that you're going to need to survive. So yes, if all you want to do is configure VLANs and configure routing protocols, eventually automation is going to take that. But if your goal is to understand overlays, again, VXLAN, learn these technologies and figure out, especially if you can tie them to business value, you're going to talk about value, you're going to be invaluable to your organization. So there's definitely a path forward. The robots are not coming for us, but at the same time, it does redefine
now.
it does redefine our role. So pay attention to that.
Yeah, that is awesome, Jeff. I really appreciate it. I was taking a look through some of the questions here. I've answered a few in the chat along the way as well, but there was one in here about management of virtual machines, and Jeff was just talking about the importance of orchestration and management layers. When I think about that piece that connects cloud computing to the enterprise virtualization world, it's in that management layer. That is where the self-service part of cloud computing comes from. The idea that Jacob can get an idea, log into a web page, and build these resources with just his credit card on his back is very liberating. And it is the disruptive factor that cloud computing has put into the industry, because we can compete. Me and my yurt here, I can compete with large vendors out there who have the same exact tools that I have access to now, as long as I'm willing to budget for it. And I love the management layers are so critical there. So yeah, kind of going back to what you guys were mentioning there. The management layers provide visibility. They provide the ability to create, destroy, and affect the state of it. And to Jacob's point about some of the cool survivability tricks, without that management layer to manage snapshots, to manage the Delta concepts, to manage how to put all those pieces back together, those tools are not as valuable. And so I especially think of products like vSphere, and I imagine how the AWS Management Console works, and I think about Hyper-V. Those management layers are the things that we see, that we interact with on a regular basis. So when we think about learning virtualization, a lot of it's learning those management layers, really. We get the concepts, but then ultimately the tooling comes in the management components themselves. What do you think there, Jake? Anything to add?
I would say that as we are trying to get it all kind of packaged together into something that is a solution. Now, one of the questions that I was actually in the middle of answering relates to, okay, I've got this particular business scenario. I'm trying to figure out what I go with, right? Do I go with Hyper-V or VMware or a cloud solution, right? What's the right answer? And I think part of the challenge is there, as we were saying, you start with the basics, but then you find out, holy moly, there's so many options, right? There's so many paths that might be the right answer. And it is a challenge to know how to dial that in, especially when you only have so many dollars to spend. One of the things that I would say, and you mentioned in this term of being liberating, is not to overlook the management expense, because virtualization management is a full-time job. It really is. And it's a busy job, because there are a lot of moving parts. There's a lot of performance questions coming in. There's security, there's logs, there's optimization. It just doesn't end. New workloads are being brought in. Workloads increase over time. And looking at one of my favorite things about adopting a cloud solution is the fact that I can say, okay, at this price point, instead of my having to invest however many hours that it takes for me or to hire in a contractor or somebody else to be able to figure out the next level of scaling, I can pay a certain subscription fee and increase my level of scaling, and it's done, right? And it's just made that happen. So the question to ask is, in many cases, what are the goals of my virtualization solution that I'm trying to roll out? How many types of things am I trying to handle? And again, coming back to, in many cases, the most common reason that I hear people saying I'm doing something on premises and it's not going to change is because of a compliance issue, because the regulations at this point often still say, if you're managing this type of data, you don't get to have it hosted in the cloud. And I think that's going to change as cloud solutions continue to prove themselves and on-premises solutions prove themselves to be only as good as the administrator managing them.
Yeah.
It's not more secure just to have it on premise if that's, again, a buffet of hackability. Which again,
I always
is going to
call
be that's my
like
band.
a quality concern almost.
Yeah.
Buffet of hackability. I like that.
Man, I don't want to. Oh gosh, I had too much hackability at lunch today. So much.
Gonna go on to the buffet.
Somebody asked a good question in here too. And when I first got into my intro to cloud days, when I was first teaching, there would always be slides that would say, virtualization saves you money. And I'd be like, well, hold on a sec here. Every virtual infrastructure I've ever worked on was the result of tens of thousands to millions of dollars of investment to build from the ground up. And so I will just throw this one out there real quick. There's a thing called virtualization saturation. That is the point whereby you have enough capacity to maintain what you need and enough to not have to buy new stuff for the next projects. That's the saturation point. Now, if you can get to that point, then you can start your ROI discussion. But until that point, prepare to bleed, because that is one of the tricky parts of this discussion. And that's kudos to Jeff and Jacob for bringing up the value piece. So many businesses got bit by this particular thing that it's one of the biggest things that me as a solutions architect in the cloud, I have to go back and talk about how their virtualization rollout went. Oh, I see you have virtual infrastructure. Why don't you tell me how that makes you feel? And invariably the discussion goes sideways because it was a discussion where they thought they were going to improve and save money, but it wasn't without design problems and implementation problems and vendor guarantees and things that didn't go the way they expected. So that's one of the things I think is crazy cool about the cloud, is that I can get those tools guaranteed to work the way they said they would without having to gamble on the ROI piece. I'm not sure what you guys think about that, but you know that getting to those new tools, there's that lift, and that is a big problem for the business. So virtualization can definitely help with that, but you need to get to a certain point with it. Do you guys agree or disagree?
Yeah, I mean, when we're talking about the way we spend money in organizations, there's this CapEx concept and OpEx. And so for those who aren't familiar with it, number one, we as IT folks in the 2020s now, we need to be comfortable with having these business level conversations. We want to be providing value to the organization. So get comfortable with some of these financial terms. But CapEx is capital expenditure. That is when you're going to go out and buy a bunch of stuff. So it's you going to the CFO, chief financial officer, and saying, hey, I need $100,000 so I can build out this virtual infrastructure. That's a CapEx spend. An OpEx spend is operational expense. That's when you're saying, you know what, we're not going to buy $100,000. We're just going to go out to the Amazon cloud and spend $5,000 a month or what have you. And so different CFOs respond differently. OpEx usually costs more in the long run. You know, if that was truly the math that I just gave you, $5,000, if I wanted to sign a check this month for $5,000, that's a lot easier than signing a check for $100,000. But you multiply it out, say, well, $60,000 a year, it's not going to take long for that $100,000 to actually be cheaper. It's not in every case, but it is in a lot of cases cheaper to do things with CapEx. Now, when you look at, well, now, you know, Bart mentioned earlier, you've got to have an expert on hand to make sure that this is running smoothly. You usually have to have a lot of those same experts for your cloud deployment, but either way, the expertise is different. You have to run those numbers and figure it out. But I've always believed that it's less about the total value dollar amount, right? I mean, like maybe one's cheaper than the other or more expensive. It's more about how you want to manage your data. And so, yes, if there's regulations or if there's just a warm fuzzy about having your own data, I mean, that's a real thing, right? It's how we all make our decisions, is what am I most comfortable with?
Yeah.
And I mean, I've been in consulting for 15 years in the industry, and I wish I could say that going to the whiteboard and you know, me documenting it out and whiz bang features and all of that, that's what people made their decisions on. People make their decisions just like you and I make our decisions about where am I going to take my car for a repair. Probably not the place with broken windows, you know, on the side and, you know, a for sale sign in the front and one mechanic inside. I don't know. I'm painting a weird picture here, but, you know, I'm going to go to the nice looking place and maybe they're going to charge a little more. Maybe they don't, maybe they're worse at their job, but I feel more comfortable going to the place that looks nice versus the place that doesn't. And so we don't always, we as humans, we like to think that we're, you know, all logic. We're not. We're so emotional. So the CFO, some CFOs prefer OpEx over CapEx. Some prefer CapEx over OpEx. It's just how they want to manage their monies. And so having that business level conversation with them, I tell you what, again, you want to make yourself invaluable to your organization. You go to them and say, look, we're talking about this as a CapEx option. We're talking about this as an OpEx option. You know, you, Mr. CFO, why don't you weigh in on this? And it blows our minds as technical people sometimes to think, well, but the CFO doesn't know the difference between a VMware and a Hyper-V. It doesn't know the difference between, you know, an Azure and an AWS and serverless, and, you know, like they don't, of course they don't understand that. But to allow them to weigh in on this, because that's a business level decision, shows your willingness and understanding that my job here is to improve the business and make sure that we stay in business and that we all have jobs next year.
Most of us are not the end product. We are the grease that keeps the wheels turning.
Yeah.
That's a good analogy, Jacob. I'm going to remember that one. Yeah.
Well, hey, friends, we're getting down to kind of the end of our meeting here. What I wanted to leave you all with is that we had a whole bunch of questions that people sent to us, and Jeff and Jacob and I went through those questions in advance. That's part of what drove this discussion that we were having today. So even though maybe we didn't answer them like, read question, provide answer, read question, we were very much guiding this through much of the topicality that people had given us already. That being said, we did answer some questions there live in the question channel. We're still available over there in Slack, and we're also going to be doing some follow-up questions, so keep an eye on the CBT Nuggets blog as well. We'll definitely try to answer some of the more topical questions here. Really appreciate everybody participating, answering polls. Beyond that, though, I really appreciate everybody hanging out. We will be doing another tech panel coming up here in a couple of months. We'll let you know what that topic is going to be on and how to get your questions submitted. If you didn't get your question answered today, reach out to us. We will try to get it addressed to you, and you can find me on Twitter at CloudBart. I'll hand it over to Jacob. You can give him his social details there.
Oh yeah,
Your social
at
security number?
Jacob on Twitter, and yeah, keeping it real, keeping it virtual.
At
Major
Jacob.
Jacob.
Yeah.
Major Bacon?
Major Bacon Jacob is the Twitter handle. Yeah. Major Bacon was already taken, so Major Bacon being a sweet anagram for Jacob Moran.
That is amazing.
And Jeff, how can we find you?
There's no way my name forms any kind of anagram other than some kind of fish. I don't know, but so on Twitter I'm at Kish Squared. It's kind of an odd one, but Kish is my last name, Kish Squared, because I was born in a family with multiple siblings, and so I was the second one, and so I just added a 2 to my name for a lot of things, so Kish Squared. And then yeah, and then LinkedIn as well. Reach out on LinkedIn. I think all of us are, you know, we're posting a lot to LinkedIn right now, so give us a follow or reach out if you want to connect on LinkedIn. And I think you'll start to see, you know, Bart, you post some of your YouTube content onto there. Jacob, I see you posting things as well, just from like, you know, the VMware study group and such. It's a good way to get reminders of what's going on. We try to be very active in alerting everybody to these kinds of events.
Yep, so subscribe and follow along on there. We will have study groups coming up. On the February and March schedule is getting going right away. So make sure you find out what clever anagrams you can produce from your name as well.
No anagrams found.
Jack did share our learning links there in the chat channel as well, though. So if you want to grab those links. Jacob, Jeff, I really appreciate it. I'm going to hand it on over to Jack here, and we'll see you guys in the next tech panel. Appreciate your time.